Welcome back. Today we'll be working on 8.4 day 2 notes. Again, we'll be solving quadratic equations, standard forms by factoring. Before we get started, let's go ahead and quickly review what the zero product property was. That's what we learned in the last video. So product means multiplication. The zero product property means if A times B is equal to 0, then what do we know about A or B? We know either A is 0 or B is equal to 0, or both A and B are equal to 0. Let's just quickly review solving from the zero product properties from the last video. So for example, let's start with example number 2. If you notice, the right-hand side is already factored. I have 2x minus 3 times x minus 8. I multiply those two binomials together, I'm going to get 0. So what do I know about the zero product property? I know either 2x minus 3 is equal to 0 or x minus 8 is equal to 0. I'm going to go ahead and solve for equation. My first equation, I'm going to add 3 to both sides. So 2x is equal to 3. 5 by 2. X is equal to 3 over 2. That's my first solution. And my second solution, I'm going to add 8 to both sides. X is equal to 8. So my solutions are 3 over 2, 8. That would be the answer that you would write on the line. Again, write it from least to greatest. Now let's go ahead and look at the difference between 3 and 4. As you notice, both number 3 and number 4 are already factored. Here I have a 2x in front, and number 4 I have a 4 actually in front. One of them you ignore the first term, and then the other one you actually set it equal to 0. So actually in 3, we're going to set 2x equal to 0 for the passive variable, as well as x plus 3 is equal to 0. Here, we don't set 4 equal to 0, because what I just wrote, does that make sense? No, because 4 equals 4, not 0. So number 4, we're just going to set x plus 3 is equal to 0, and 5x minus 1 is equal to 0. Let's jump back to 3 to solve. I got to get x by itself and divide by 2. X is equal 0 divided by 2 is 0. To subtract 3 to both sides, x equals negative 3. So the solution is negative 3, 0. And quickly, let's just go over 4. And if I subtract 3 to both sides, x equals negative 3. You're going to add 1. So 5x is equal to 1. Divide by 5. X equals 1. So my two solutions are going to be negative 3, 1/5. Again, least to greatest. Alright, so now from the last video, we actually added another step to these types of problems. So see how they're already factored? Now what we're going to do is factor them first, and then go ahead and solve using the zero product property. So let's look at number 5. Again, first rule of factoring, always check for a GCF. Look at number 5. I don't see a GCF. I'm going to zoom in just a little bit. I'm going to go ahead and write the factors into the square. Y multiply x and x. All the factors of negative 24. If it's a negative, then there's one number in each combination will be positive, the other one is negative. Negative 1 and 24. Negative 2 and negative 3 and 8. Negative 4 and 6. Now we're looking for a combination of x and negative 5x. But if you notice, negative 3 and 8, when I add those together, I'm going to get positive 5. But that's an easy fix because I don't want positive 5, I want negative, so we're going to flip flop negative 5. Then we'll do with 8. My factors are going to be x plus 3, x minus 8. I replace the negative 4 and 6, a little extra room. And then, biggest mistake, people always write f of equals 0. You need to equal 0 because in order to do the next step. Now, we're going to solve by the zero product property. I have x plus 3 times x minus 8 equals 0. I multiply those two things, I get 0. So by the zero product property, I will get x plus 3 equals 0, or x minus 8 equals 0. So I'm going to back 3, so x equals negative 3, and add 8 equals positive 8. So my solution is negative 3, 8. move on to number 2. Again, you look at the right-hand side, and you need to realize that you have to factor the right-hand side because it's not in their separate binomials yet, the parentheses. Again, first rule in factoring, always check for a GCF. You know this, every term is divisible by 2. So we divide everything by 2. Do not forget to drop down this equals 0. So I factored out the 2, I'm going to leave it on the outside, and I'm left with 3x squared plus 10x minus 8. Okay? We still have to factor my leftovers. Some of my leftovers are everything inside the parentheses. And it's going to be a little bit tougher because that's I'm not going to be able to see the combination right away like I did in 5. All the factors of negative 8, 1 and 8, 2 and 3. Okay, guys, drop down the 0, and then always drop down the 2. Now let's see what combination it is. Let's do 3x first, and then the next second. All right, so let's go ahead and let's try negative 2 and positive 4. Again, I don't know if that's right, I just guessed. In order to practice if it's right, I have to do this step, my inner and outers. Negative 2 times x, that's negative 2. Outers, 12x. If I add those two together, I get switch up. That's exactly what I wanted. But again, this purple right here is not part of the answer. That's just checking to see which combination we're working with. From here, we're going to set 3x minus 2 equals 0, x plus 2 equals 0. And don't forget, we're going to ignore the 2 because there's no variable attached to it. Anytime there's just an integer or a constant, anything, we just ignore it. So I'm going to set 3x minus 2 is equal to 0, x plus 4 is equal to 0. We're going to add 2, so x is equal to 2, and then 5. So x is equal to 2. Here you must subtract 4 to both sides, x equals negative 4. I get the solution here are negative 4 times 2/3. Alright, so that is a review from the last video. What we are going to do is move on. So in order to get the complete 2 points for this assignment, you're going to need to do 7 and 8 on your own. Okay? Alright, what we're going to do is move on to number 9. Now, let's talk about what is different about number 5. Okay? First thought is probably saying that it equals 4, which you're right, it does equal 4. Do we want it equal to 4? What are all the other questions that we dealt with equal to? They're already equal to 0. The first thing that you're going to do is get this equal to 0. But we got to figure out, should I move everything to the left side or the right? And the answer is that is always look at the quadratic. This is just quadratic from right here. The exponent that is a 2. That always has to be positive. So make it positive. If it's already positive on the left, move everything to the left. If it's on the right, keep it on the right. But look, I have a negative quadratic term on the right. I don't want it on the right since it's negative. So we're going to move everything to the other side of the wall. So remember, if I move negative 5x squared to the other side, I'm going to add it. So add 5x squared. Then I got to move 9x squared. I will subtract. Now, the equal sign drops down. 9x minus 9x is 0. Negative 5x squared plus 5x is 0. So there you go, I got it equal to 0. Now, I cannot combine any of these 3 terms. So I'm just going to have to write them in standard form, not in order. So you're left with 5x squared minus 9x plus 4. As you can see, this problem now becomes the problems that we've done in 5 and 6. I'm just going to factor and solve. Again, always check for GCF, but there's nothing. Everything that multiplies to 4 is 1 and 4, 2 and 3. So if you recognize this is a term, so I know both of them are going to be negative. You're going to again guess and pick a combination. Do not pick a combination that equals 0. Let's try negative 1. That's the combination. Let's double check. So again, I don't know if it's a combination until you're doing this work in the green inner and out. Negative 4x in my inners, negative 5x in my outers. I add those together, I get 9. Is exactly what I want. Again, this screen is not part of the work. checking to see which combination to use. From here, I have 5x minus 4 times x minus 1 equal to 0. Well, for the zero product property, I know that either x minus 4 is equal to 0 or x minus 1 is equal to 0. So here, I'm going to, my first equation, I'm going to go ahead and add 4 both sides, so 5x is equal to 4. So x is equal to 4 fifths. Here, I'm going to add 1 to both sides, so x is equal to 1. My two solutions are 4 number 1. Sorry, I kind of ran out of room right there, so I didn't have to write it. All right, let's move on. Next question. Again, you should recognize this equation is not set equal to 0. So we're going to draw the line around under the equal sign. You have to figure out, is everything going to end up on the left side or on the right side? And how you figure that out is you look at the quadratic term. See how your quadratic term, 2x squared is already positive? So we want to keep it positive. So we're going to move everything to the left side. If I move 9m to the other side of the equal sign, I got to shift it. Okay? Now notice I cannot combine any of these three terms because these three terms are not right. So they're written in order. I have 2m squared minus 9m minus 18. Drop down the equal sign. What's 9m minus 9m? 0. Again, this becomes a problem that we've already done in 5 and 6. Factor to solve, because we have to factor the left-hand side. So it's like always check for GPS, and you recognize that you can't divide 9 by 2, so you can't just take out a 2. Here I'm going to have 2m and m. Everything that makes negative 18, negative 2 and 18, negative 2 and 9, and negative 3 and 6. All right, let's check to see the combination. Again, do not keep forgetting to set that equal 0. Let's see. Say minus 6 plus 3, I think is the combination. Again, I don't know until I check the inners and outers. So I have plus 3m, oops, sorry, minus 12m, yep, that equals negative 9m. As was the correct combination. Again, the part of the purple is not part of the answer. It's not just checking to see what combination. So here, we're going to use the zero product property. Remember, 2m plus 3 times m minus 6 equals 0. So by the zero product property, the product means multiplication, we either know 2m is equal to 0 or m minus 6 is equal to 0. Solve both equations to find the both solutions. Here, I'm going to subtract 3 to both sides. 2m plus negative 3. Negative 3 over 2. Here, you're going to add 6 and equals 6. So my two solutions are negative 3 over 2 and 6. Okay, let's go ahead and flip it over. Let's see what problem we should do. Let's go ahead and do number 12. Again, let's go ahead and draw the line under the equal sign. We should recognize this clearly is not set equal to 0. We have to get the equation set equal to 0 in order to factor. That's the first rule. And to figure out if things end up on the left or the right, it's our quadratic term. Their quadratic term is negative. Since it's negative, we don't want it to end up on the right. We need to move it over to the left because it always has to be positive. So move negative 3 squared over, we're going to add 3a squared to both sides. Right? And then again, I'm going to move 1 over. But I'm not going to put it right up to the negative 4 because they are like terms. From here, I'm going to go from 3a squared plus 14a, then negative 4 minus 1 is negative 5. Drop down the equal sign, that cancels out, that cancels out, so it equals 0. Same step, factor to solve. Then here, always check for TCF, but there is none. Like 3a and a, I have negative 1 and positive 5. So again, I don't know if negative 1 comes first or 5 comes first. Let's check. Again, equals 0. Looks like I'm going to have negative 1. Let's positive 5. Again, this work is not part of the answer. It's just checking to see if I picked the right order of the combination. Negative 1a plus 2a. Are those together? Yeah, it's 16a So now I pick the right combination. From the zero product average to 3a minus 1 times a plus 5, what do I know? I either know 3a minus equal to 0 and a plus 5 is equal to 0. Solve both equations to get both solutions. Add 1 to both sides, so 3a equals 1. Divide both sides by 3, a equals 1/3. Here, subtract 5 to both sides, a equals -5. My two solutions are -5, 1/3. All right, let's go ahead and move on. Let's actually move on to number 14. Again, if there's any problems that I do not complete in this video on these notes, you are still required to do them to get the full 10 points in your packet. Now, 14 looks a little bit complicated. So again, I'm going to stop. You notice that two quadratic terms here? You have 12x squared and -14x squared. Well, do you remember from first semester with solving equations, which one do you always move? You always move the smaller one. So between 12 and -4, we're going to move the -4. So we're going to move everything to the left. Move -4x squared to the left side and add 4. Add 4. Move -3x and add 2. I'm going to put it right under the 3 exponential the right term. So I have 12x squared, 4x squared, that's 2x squared. Here we're going to move on to my x's. Look, I have -3x plus 3x. That's perfect. So I'm just going to drop down to -81, drop down the equal sign, and that equals 0. Now we have to factor the left hand side. We should recognize that 4 squared is 8, 9 squared is 81. Oh, sorry, 81. This is the difference between perfect squares. So remember, I'm going to split 16x squared as 4x and 4x. I'm going to split up -81 as 9 and -9. So my factors are going to be 4x plus 9 and 4x minus 9 is equal to 0. Again, by the zero product property, you're going to set 4x plus 9 times 4x minus 9 equaling to 0. So I'm going to set 4x plus 9 equals 0 and 4x minus 9 equals 0. So for our first equation, I'm going to subtract 9 to both sides. So 4x equals -9. Divide both sides by 4x equals -9 fourths. Here I'm going to add 4 equals 9. Divide by 4, x equals 9 over 4. My two solutions are -9 over 4 and +9 over 4. All right, let's go ahead and check out the next problem. Let's go ahead and complete. But you know what? Let's just go ahead and finish up with number 13, and then we'll call it a day. So again, this is clearly not equal to 0, so let's go ahead and draw the line. Again, we have to figure out which side are we going to end up on, the left or the right. And it determines that question by your quadratic term. Always move the smaller term. So between 4x squared and 2x squared, we're going to move the 2x squared. Move the 2x squared all the way to the left, so we must subtract it. Again, I'm going to write it right under because we know that I'm going to combine it. Here, I'm going to add the 5x, put it right under the f because I'm going to combine them and have 15 right there. All right, so 4x squared minus 2x squared, that's 2x squared. 5x plus 5x is 10x. And then we'll drop down to 14. Drop down the equals and 0. Yeah, always stop for a GCF. And if you notice, everything is divisible by 2. So the 2 out in front, I'm left with x squared plus 5x plus 7 is equal to 0. Alright, always check to see if you can factor further as x and x to 1 and 7. Now, we should be running into a problem right now if you recognize the only two numbers that multiply to 7 are 1 and 7 are -1 and -7. Both those variables do not add to 5. So this equation, again, cannot be solved by factoring. Because remember, every binomial or binomial is factorable. We're going to learn how to solve this type of equation that can't be factored in 2 videos from now. It's called the quadratic formula. So go ahead and finish the rest of the problems on the notes and complete your homework.